Good morning, class. So at this point we are looking at the examples for exercise 1.5 on page 11. Is that correct? This is 1.6. It's right, 1.5. Okay. Okay, so just something here quickly. We are saying it's examples for exercise 1.5, or should it be examples of exercise 1? It's 4 correct? You sure? Okay, I think the grades 10 said it was of. They're wrong. So why must it be of and not for? Oh, that makes sense. I asked them, they said no, it's of. And so I asked them why, so they said it sounds right. Okay, I also don't know. So I did maths in my English bit, which is not right, no? Because I could have had the right answer for them. Right, but anyway, that's how it goes. So solving equations with rational exponents. When solving equations with rational exponents, we need to ensure that the answer is a real number. People, what does real mean? It can either be an integer, a natural number, a whole number, rational or irrational. If something is non-real, it means to say it doesn't exist to us. Okay, you guys understand? Exercise 1.6. And the page? Or is this the next one? I'm on the right place, no? And page? 11. You sure? Okay, so it's the exercise is on page 13, then that's what should read here. Okay, the exercise 1.6 on page 13. So remember the definition where the nth root of a to the m is equal to a to the m over n. We will use the definition to solve equations with rational exponents. Example, and then we can see the cube root of a squared can be written as a to the 2 over 3. Remember that the denominator will be the root and so on. Okay, by definition, we also know that the square root of 25 is 5. Negative square root of 25 is negative 5. And plus minus the square root of 25 is plus minus 5. Okay. Also something to note at this point is the square root of negative 25 is non-real. Okay, or imaginary or whatever. Okay. At this point, you guys will just say it's non-real or it doesn't exist. Okay. When you go to university, and for those of you who do AP maths or advanced maths, you go to a whole chapter dealing with non-real stuff. Okay. Right, here we go. The question says solve for x. Alright, so if we're looking at this here, how do we get rid of, okay, so what does this mean to us? This is actually the square root of x equal to 3. So how do I get rid of the square root? I would square both sides. Not so. So x is equal to 3 squared is 9. Not so. But look on this side. So if I put 3 and 9 back into the sum, or here under the root, the square root of 9 is 3. Okay, just make that correct. Well, look here, however, the square root of x is equal to negative 3. Okay, what do I do here? Also square both sides. Not so. So that's going to give us 9. But what is the square root of 9? 3. But this gives you negative 3. So can this be correct? No. So there is no solution. Okay. So there at this point you say no solution. Which means to say there is no real value for x, which will make that statement of the square root of x equal to 3 for it to be real. Or exist to us. You guys understand? So there is no solution. So now, how would we have known if it was coming from the fact that x to the half is equal to 3? So to get rid of the exponent or half, I would square both sides. Not so. So what's our half times 2? 1. And that's what I want. That's why I chose 2 in particular. If it was 3, then I would have said raised to the power 3. So 3 squared is 9. So that is fine. However, on this side here, 1 over 2 is equal to negative 3. So I need you guys to make a note at this point. Is that if the denominator is even, if the denominator is even, the number has to be positive. Okay, I'll pause the video at this point. If the denominator is even, the number has to be. So if the number is not positive, it will be. You just write there, draw the line and say no solution. Okay. Let's carry on. The example, these are the examples on page. Sorry? Example page 2. Okay. So if I look at this here, so this would simply be the cube root of, this would simply be the cube root of x is equal to negative 1. So how do I get rid of the cube root? We will cube both sides, raise it to the power 3. Okay? What is, so that cancels, that's what we want. So x is equal to, what's negative raised to the power, negative 1 raised to the power 3? Negative 1. Not so? Okay? I take this into account. How do I solve this one? I would square root both sides. If I introduce square root, plus minus. Not so? So this will be x is equal to plus minus. Alright, so now let's work. Here we are working with radical with square roots and cube roots. Let's work with exponents and see what happens. What if we add x to the third raised to negative 1? Okay? Is this denominator even? No, so then number being positive or negative doesn't matter to us. Not so. If it was even, it had to be positive. Yes. Not so. So what do I raise this to get rid of that exponent? What exponent should I raise this to? 3. 3 over 1, eh? And that's also 3 over 1. So that is cancelled, so that gives us x equal to minus 1. We use the exponent on this side, let's see. So it's x squared is equal to 4. What exponent would I raise this one now to? What's the reciprocal of 2? The reciprocal. What's the reciprocal of 2 over 3? 3 over 2. What's the reciprocal of a third? 3 over 1. So what's the reciprocal of 2? Half, yes. 5, so that's 2 over 1. Not so? Huh? Yeah. Okay, so I'm going to raise it to the exponent. So that side also the exponent of. So that cancels, not so? So I say x is equal to, this could have been written as 2 squared. Not so? So 2 times half is 1. But are those answers the same? No. So now another note you will have to make. Okay? The second note is, it will naturally over 1. If the numerator is even, To add the, if numerator is even, add plus and minus to the right hand side. The numerator is even, add plus minus to the right hand side. So if the numerator is even, let's add plus minus to the right hand side. Okay. So by doing that, you will say, okay, that's even. There goes plus minus. Okay. You all okay with that, people? Right. So just something to look here, to note here. To summarize, in an equation involving rational exponents, by definition, are positive or zeros. That's the equation. These are non-real because why? But the denominator is even, the number has to be positive. Can be positive or negative depending on the value of x, so that doesn't matter if it's that exponent. Right, let's look at example 1, and this is the example on page 13. Example 1 on page 13. So the question says solve for x. Okay, so what do we notice here, people? What is even? Denominator. So the number must be? Is it positive? Yes, our life can carry on. Our lives. So you say x, 3 over 4 is equal to 8 can be written as 2 raised to the exponent 3. Not so? So how do I get rid of 3 over 4? You raise it to the exponent 4 over 3. Okay. So that cancels, gives us x is equal to, there's over 1, so that cancels. 2 to the exponent 4. What is 2 to the exponent 4? Okay. You all understand? Okay. Look at example 2 on page 13. Okay. So here we are told to solve for x. We got x to the exponent 2/3 equals 4. What's the rule if the numerator is even? Add plus minus. So you say x 2/3 is equal to 4 can be written as 2 squared. So I must raise this to what exponent? 3 over 2. And here goes plus minus. Okay? So that cancels. So x is equal to plus minus 2. What is 2 multiplied by 3 over 2? 2 multiplied by 3 over 2? 3. And 2 cube is? 8. And you can test it. You can put that in your calculator and see if it's good. Will you guys understand? Any confusion? No. Okay, and then that is tomorrow's lesson. Not so? No, that's not part of this. Alright, so this now takes us to exercise 1.6. Okay, you do for me the odd numbers out of exercise 1.6. I will check your books and see that you guys are on the right track now. Okay, I'll stop the video at this point.